Good evening, everyone. How are you? This is Mr. Murray, and we're going to talk about parabolas like you've never seen them before. It's actually a pretty cool topic. Up until this point, it was definitely, in my mind anyway.
Someone say crazy person?
No? Well, I heard it.
This is a parabola, right? And that would be x squared. And then this guy would be negative x squared. I'm just sketching. It's nothing fancy. What do we say here? There's a vertex and an axis of symmetry. Okay, on this guy, this is the vertex because it's at the top. Axis of symmetry, right down the middle. Let me take this one and make it a little more realistic. Here we go. Move that over. Yeah, what if it was like that, right? Axis of symmetry, right down the middle. Vertex, right at that turning point there, the minimum in this case. From this point forward, we're going to know that parabolas can be defined using this thing called the focus and the directrix. The focus is a point on the plane that will always lie on the axis of symmetry. All right, well, let's just come up with something like this then. An imaginary parabola. We'll throw it over to the right, let's say. Okay. So where's my axis of symmetry on this baby? I would say like this, right? Okay. So a focus is a point that will lay on that line, somewhere on that line. And the directrix is a line that will always be perpendicular to the axis of symmetry. Okay, so perpendicular means running this way, right? Opposite. Negative reciprocal slope, you geometry fans out there. Look, 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 right triangle. I love it. Right angle. Okay, that's perpendicular. Here's the really cool thing about parabolas. They are actually, the red thing you're looking at here, it's a collection of points that, believe it or not, are equidistant from this thing called the focus, which is always inside the salad bowl, is how I like to say it. It's sort of like a satellite dish, right? You got this thing on your roof. It's the satellite dish, and the signals are coming in from the Martians. And you ever see how it has like a little circular receiver thing right there? And it's kind of like inside that dish. Well, that's the focus. It's so wicked. So when these signals come in, they bounce off the curve of the dish and they hit that antenna. This guy coming right up the middle bounces off the back, hits the antenna. This guy on the edge catches the rim and the angle deflects it right to that antenna. So that thing's the focus. If you look at anyone's house that has DirecTV, you'll see that. So that's how you should remember. The focus is always on the inside. And a parabola is always scared of the directrix. It runs away, it goes opposite. This point here from the focus to the parabola is the same as the distance from the parabola to this thing called the directrix. And then it works in any way. The distance from there to there is the same from there to there. The distance from there to there is the same from there to there. Okay, it doesn't look like it in my sketch, I understand, but there's a better picture coming. But that's generally the idea. Given that information, the focus business, this directrix, we can come up with a parabola in this form. And the H and the K still stand for vertex, which would be this guy right here. But this P thing that we're introducing is this. It's that distance right there, or the distance right there. You'll notice that they're the same, right? They have to be. The definition says a parabola is a collection of points equidistant from the focus and the directrix. So you would agree that these are, of course, the same. But anyway, that's P. So when we do a bunch of problems like this, sometimes you won't have a vertex, you'll only have a focus. And you might have just a focus and a directrix. So you try to figure out, well, what's P? You'll know it's half the distance from this directrix line up to the focus. So you'll get very used to these ideas, and they'll become simple to you, I promise. That was what I was trying to draw. I stole this from the internet. It's much better looking, I think, than what I did, but it's the same idea. These are the components, and I need you to get very comfortable with those, okay? Very comfortable. Now, one thing to tell you about P. Since you already know that x squared looks like this guy, and negative x squared looks like this guy, I want you to know that this distance p right here, or this distance p right here, which is this part of the equation, if p is negative, we go down. And just the opposite, if it's positive, we go up. Nice. Given a focus of 0, 4. Okay, we're just literally going to walk over to 0, 4 and make us a focus. Hocus pocus, look at my focus. Call that F for focus. Directrix, y equals negative 4. Now remember, it's always perpendicular to the axis of symmetry. It goes left to right, and this is my D, Directrix. Define the equation of the parabola in vertex form and sketch the result. X minus h squared equals 4 times that little p distance, parentheses, y minus k. Now, h and k are the vertex, right? I don't have that. So this is where you need to get comfortable with the structure of this and realize, wait a minute, the vertex is halfway from the focus to the directrix. I know this. It's always halfway between. So let me take a little red here, and right there, that's halfway, right? That is my vertex, V. So I can write in my notes on the side, vertex, which is HK, equals 0, 0. Okay, what about my P? I'm missing that in this thing here. Okay, well, P is the distance from the vertex to the directrix, which is 2, 4. 4. Why'd I make it positive? Because I know, being that I'm comfortable with this structure here, that the parabola is always open away from the directrix, and the focus, like a satellite dish, is always inside. So I'm going to say that my parabola opens upward. Now, I'd like you to do the following. You can't just sketch this thing. You know, I don't want you to just walk over and do this. La 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 la. You know, that's no good. I mean, it's probably pretty close, actually, now that I look at it. But I want you to get 2 more points, okay, so that we can make this a really nice sketch. So I'm going to put this back over here for now. What I want you to do is find 2 points based off of the focus so that you can tell how wide or how narrow should this thing be. So measure the distance from the focus to the directrix, and you'll notice that it's 8. 2, 4, 6, 8. So from the focus, I would just like you to go to the right and to the left, 8. 2, 4, 6, 8. So over there. What color am I doing? Blue? Okay, hang on. Okay, 2, 4, 6, 8. And then go to the left, 2, 4, 6, 8. You know, at least this will kind of give you the idea of how wide to go. So my parabola is actually pretty wide. It hits the vertex, and then it goes back through those. Okay, put my arrows on, talking about going to infinity. Perfect. Now, you kind of see what I mean, right? Like, look, if I stuck with the quick sketch, not so good. This is actually a wider salad bowl. Standard form. To get it into standard form, actually, first to get it into vertex form. Murray, you're way ahead of yourself here. Okay, sorry. Let's do this first. Let's fill in what we know. So the h and k are 0, right? So x minus 0 squared equals 4. P we determined was positive 4. And y minus 0. Okay. Simplifying this a bit, we get x squared equals 16y. That's pretty cool. Now, standard form would be actually pretty simple for this one. We want it to look like y equals, right? Y equals ax squared plus bx plus c. So you take this and make it y equals. Well, we're just going to divide by 16. So this one's going to be y equals 1/16 x squared. So my a value is 1/16, My b is non-existent, so it's 0, and my constant non-existent, so it is 0. So this is a very, very basic parabola, as you can see from this standard form. But when we put it into this modified vertex form, with the h's and the k's and the p's, you can see it's very different. Let's try the next one.
Teacher, can I use the bathroom?
I don't know, can you?
I don't know, can you get a full-time job?
Vertex at 2, 1. Go over to 2, go up to 1. That's my vertex, I'll put a V there. I have a directrix at -5, so that's all the way down here. I'll put a D there. Define the equation of the parabola in vertex form and sketch the result. I know that a parabola opens away from the directrix and that the focus has to be inside. Well, if this is the vertex and my parabola opens away, my parabola is looking something like this. So my focus has to be somewhere in here, or up here, so to speak. Well, where will it be? It will be exactly the same distance from here to there, from the vertex to the directrix. So what is that distance? It's 1, 2, 3, 4, 5, 6. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. That, my friends, is the focus. Always inside the salad bowl. And now we just have to figure out, is this wide? Is it not wide? Let's take a look. Vertex HK is actually going to be 2, 1. My P we just figured out was 6. Let's go over from the focus. How many? Wow, this is a lot. It's going to be the distance from the focus to the directrix. I want to go right and left so I can be a little more accurate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Makes sense. It's 2 times the p-value. That makes sense. All right, so let me go to the left 12. 2, 4, 6, 8, 10, all the way off the chart over here. And this is going to be crazy. 2, 4, 6, 8, 10, way out there somewhere. So my parabola, when I sketch it, looks like this. Really wide. I'm going to stop there because I ran out of room. Sorry. And there's my parabola. I just sketched it. Check out the structure. Vertex at the bottom. Focus along the line of symmetry. Inside the salad bowl. Directrix underneath because the parabola always goes away from the directrix. This is pretty cool. Let's put it into proper format. X minus h squared equals 4 times p. My p is positive because this guy's smiling. Times y minus k. Make it a little more fancy. X minus 2 squared equals 24. Y minus 1. There you go. Modified vertex form right there. Next part of the question is, let's put it into standard form. Now for this, we're going to have to do a little bit of work, not like the last one. This guy, we're going to have to blow out. We're going to have to distribute here, and then get y all by itself. So I think we're all pretty good at this. So let's skip ahead, the box method, and let's go to the final answer there. X squared minus 4x plus 4 equals 24y minus 24. Moving everything over, getting y by itself. Add 24. Add 24. Okay. X squared minus 4x plus 28 equals 24y. I think you'd agree that we'll divide by 24 and we'll be out of here. Let me just delete that. Okay. Now this I want you to be careful with. Seriously, hang in here for one more second. I'm going to divide by 24. But I want you to see what my answer looks like. I'm going to put the y on the left. I don't know, it's just the way I like to make it sound, because it's y equals, right? I want you to break these into separate fractions and have them reduced so that we can do that standard form of ax squared, bx, and c. So let's do 1/24 of x squared minus, this is 1/6 for those of you playing at home, 1/6 x. And this is positive 4, I think, goes into both of these, so 7/6. And that's going to be positive 7/6. So here's my standard form in ax squared plus bx plus c format. And this is my modified vertex form, where we can start looking at vertex, directrix, p-values, and all of that. But in the end, these are two very similar things, you would agree. These are just different ways to represent this parabola right here. I must say that you'll always have fractions here. Miss Sanfini and I have always tried to find out a way that the standard form would not have fractions, and we just can't. So when you're dealing with this focus directrix stuff, and you ever put it into standard format, it's always going to have these fractions. Sorry about that.
We'll bring you on into the temps, and we're all doing okay. Wow, 750 degrees in Gila Bend right now. And 1,270 in Ahwatukee. Now, I'm not authorized to evacuate Ahwatukee, but this temperature seems pretty high.
Cave Creek is really...
Yeah, Cave Creek, Fountain Hills, they don't look good either. And frankly, Wickenburg is a total loss. You might as well just get out of anywhere along this 60 here. It's very warm. Surprise is starting to heat up as well at 1,300 degrees. So again, the safe spots seem to be Chandler and Mesa. Scottsdale is doing okay so far, but you know, you're sort of surrounded by some pretty intense heat. So, you know, again, I'm not your dad, but I would get out while you still can. I think steel boils at about this temperature, so Cave Creek, there's probably nothing left up there right now. So don't even bother looting up there. It's not going to be worth it.
This guy, vertex 2, -1, right there. That's my vertex. Directrix up top with a 3. That's all I know. Okay, so vertex, I know that's the tip of the parabola. I know parabolas open away from the directrix, so we're going to start doing something like this, right? So that means my focus is somewhere in here now. So this is a downward dog. This is yoga. This is a downward parabola. Where does that focus live? Well, it's exactly the same distance from the directrix to the vertex. So what is that distance? 1, 2, 3, 4. So let's do 4 more. 1, 2, 3, 4. Right there is my focus. This is vertex. So if I want to sketch it, let's count how far am I away from the directrix from this focus. 1, 2, 3, 4, 8. Okay, so I'm going to go to the right 8, 2, 4, 6, 8, right there. I'm going to go to the left 8, 2, 4, 6, 8. That'll tell me how to, oh God, this is another wide one, right? This will tell me how to sketch this parabola, at least with a little bit of accuracy. Very cool. Focus inside the salad bowl. Parabola opens away from the directrix. Vertex is on the same axis of symmetry with the focus. Everything lines up beautiful. These are perpendicular. Not bad. It's a nice structure. But now let's make an equation out of this. Since it's opening down, I think I'm looking for a negative p. Wouldn't you agree? -4. Okay, so vertex 2, -1. P, -4. X minus h squared equals 4p y minus k. Notice it's positive, double negative, right? Double negative, just in case you missed it. Let's make it look pretty. This is my modified vertex form. I'm out. Done. Now, standard form. Let's make it y equals. So you know that this already is x squared minus 4x plus 4. And that's equal to -16y minus 16. Move the 16. And then we're going to divide by 16. And we're going to separate them into nice chunks. So I can have my A, my B, and my C. Now, this is the point I wanted to stop and just mention. a little bit of value add here. Pro tips. You know this parabola is opening downward, right? So why was that negative p so important? It came in right here, right? Here's my negative p. The reason why it works out is because this will then become negative. And as you can see in standard form, you've got to divide this away, right? But look, now you're dividing by a negative. So what does that do? It makes the coefficient of my x squared negative. And you already knew walking into this video that a negative x squared opens down. So that's the tie-in with the p. When your p is negative and it goes to standard form, you can see very clearly that this is a downward opening parabola. So it's negative 1/16 x squared. 4 divided by 16 is positive 1/4. So my b value is 1/4. And my c value is negative fraction again. Looks like 4 goes in, right? So 5/4. And that's standard form. Very, very cool. Okay, I hope you enjoyed checking out parabolas in a different view. And what we did here today was we took components of a parabola and found out their modified vertex form and standard form. Pretty cool. Okay, well listen, have a great night, and Zamfini and I will see you tomorrow.